Only a little more than 4 light-years from Earth lies a world that has captured the imagination of scientists across the globe. Its name is Proxima b. Although it circles the closest star to our solar system, this distant planet remains one of astronomy's greatest mysteries. We know it exists, but no spacecraft has ever visited it, and no telescope has captured a detailed photograph of its surface. Yet every year, new observations bring us closer to understanding what this remarkable world might actually be like. The discovery of Proxima b was announced in 2016 after astronomers detected a tiny, repeating wobble in its parent star, Proxima Centauri. That subtle movement revealed the invisible pull of an orbiting planet. From those measurements, scientists estimated that Proxima b is slightly more massive than Earth and completes one orbit around its star in just over 11 days. Despite this short year, the planet lies inside what astronomers call the habitable zone, the region where temperatures could allow liquid water to exist under the right conditions. That single possibility transformed Proxima b into one of the most important targets in modern astronomy. But learning about a planet so far away is incredibly difficult. Unlike nearby planets in our own solar system, Proxima b cannot simply be photographed like Mars or Jupiter. Its parent star shines thousands of times brighter than the faint light reflected by the planet itself, making direct observation an enormous technical challenge. Instead, scientists rely on advanced instruments to study tiny changes in light. Every small fluctuation contains clues about the planet's size, mass, orbit, and possibly even the composition of its atmosphere. This is where the James Webb Space Telescope enters the story. Although Webb has not captured a direct detailed image of Proxima b, its powerful infrared instruments are helping astronomers develop new techniques for studying distant worlds. By analyzing infrared light with extraordinary precision, Webb allows researchers to investigate the atmospheres of many exoplanets, searching for gases such as carbon dioxide, water vapor, methane, and other molecules that reveal how these planets evolve. Each successful observation improves the methods scientists hope to use on nearby rocky worlds in the future. Proxima b presents both exciting opportunities and serious challenges. Its star is a red dwarf, much smaller and cooler than our Sun. Red dwarfs are the most common stars in the Milky Way, meaning billions of planets may orbit stars similar to Proxima Centauri. However, these stars are also extremely active. Powerful stellar flares frequently erupt from their surfaces, releasing intense bursts of radiation into space. If Proxima b lacks a strong magnetic field or a thick atmosphere, those flares could gradually strip away its protective gases, leaving the surface exposed to harsh radiation. On the other hand, if the planet possesses a dense atmosphere and a magnetic shield like Earth's, it could still maintain stable conditions despite its active star. That uncertainty is one of astronomy's greatest unanswered questions. Computer simulations suggest several possible versions of Proxima b. One model imagines a rocky world covered by vast oceans. Another predicts frozen continents locked beneath permanent ice. Others describe a dry landscape shaped by volcanic activity and powerful winds. At the moment, scientists cannot determine which scenario is correct. Every possibility remains open. This uncertainty is exactly what makes Proxima b so fascinating. Rather than providing easy answers, it challenges researchers to invent better telescopes, more sensitive instruments, and entirely new ways of exploring planets beyond our solar system. And with every improvement in technology, humanity moves one step closer to transforming this distant point of light into a real world we can finally begin to understand. As scientists continue studying planets beyond our solar system, Proxima b remains one of the most intriguing destinations in the search for potentially habitable worlds. Although we still know relatively little about its surface, each new observation helps narrow the range of possibilities. One of the biggest questions is whether the planet has an atmosphere. An atmosphere does much more than provide air. It regulates temperature, protects the surface from harmful radiation, and allows weather and climate to develop. On Earth, our atmosphere has played a critical role in making life possible for billions of years. Whether Proxima b has managed to hold onto such a protective layer remains uncertain. Its parent star, Proxima Centauri, is famous for producing powerful stellar flares. These energetic eruptions release intense radiation that could gradually erode the atmosphere of a nearby planet. If that happened over millions of years, Proxima b might now be a cold, rocky world with little protection from space. But scientists have another possibility in mind. If the planet possesses a strong magnetic field similar to Earth's, it could deflect much of that harmful radiation. Combined with a dense atmosphere, such protection might allow stable temperatures and perhaps even liquid water in certain regions. At present, researchers simply don't know which scenario is correct. That uncertainty is exactly why Proxima b continues attracting worldwide scientific attention. The James Webb Space Telescope and future observatories are helping astronomers develop increasingly sophisticated techniques for studying rocky exoplanets. Instead of relying on a single observation, scientists combine information from multiple telescopes, computer simulations, and laboratory experiments to build detailed models of distant worlds. Every improvement brings us closer to answering questions that once seemed impossible. Future observatories planned for the coming decades may be capable of detecting even fainter signals from nearby Earth-sized planets. They could search for atmospheric gases, estimate surface temperatures, and perhaps identify chemical combinations that hint at biological activity. Such discoveries would represent one of the greatest milestones in human history. Yet even if Proxima b ultimately proves uninhabitable, its scientific value will remain enormous. Every planet teaches us something about how planetary systems form and evolve. Some worlds become frozen deserts. Others are covered by oceans or thick clouds. Some may experience extreme volcanic activity, while others might possess climates unlike anything found in our solar system. By comparing these worlds, scientists gradually learn what makes Earth so unusual, and perhaps how common similar planets may be throughout the galaxy. The implications extend far beyond astronomy. Understanding nearby exoplanets helps engineers design future space missions and inspires new technologies that could one day send robotic probes toward neighboring stars. Projects exploring advanced propulsion systems remain experimental today, but they demonstrate humanity's growing ambition to reach destinations once considered forever beyond our grasp. Even if such journeys require decades or centuries, every major exploration begins with knowledge. And knowledge begins with observation. That is why every new discovery matters. Each improved telescope, each refined computer model, each observation of a distant star adds another small piece to one of science's greatest puzzles. Are worlds like Earth common? Could life exist elsewhere in our cosmic neighborhood? Or is our planet a rare exception in an unimaginably vast universe? For now, those questions remain unanswered. But one thing is certain. Humanity has entered an extraordinary era of exploration. Every year, astronomers discover new planets, develop better instruments, and push the limits of what is possible. Perhaps one day, future generations will look back on today's observations of Proxima b as the first step toward exploring another world. Until then, that small planet orbiting the closest star to our Sun remains a symbol of curiosity, discovery, and the endless desire to understand what lies beyond our own sky. Because every distant world reminds us that the universe is still filled with places waiting to be explored, and perhaps, one day, visited.